So what we're going to focus on very briefly are the green, blue,
Yeah, rainy colour.
aqua.
Yeah. Is anything in green is significant?
So you've got the mean, you've got the standard deviation. I'm not going to elaborate on the standard deviation except that it is a measure of the variation around the mean. Okay. The F is a particular statistic. It doesn't stand for fudge or anything else that starts with F. It is a particular statistic. The P stands for the statistical probability level. Almost all social science and educational research, and also research in natural sciences, uses these types of statistics. Medical science is all about probability. And so most social and educational science is also about probability. So if we go on the first one, hearing syllables, the key one is the right-hand column, where we have what is referred to as an effect size. And that really is just a comparison of the mean for the trial group compared to the mean for the comparison group, and whether that difference is not only statistically significant but reasonably important. Now an effect size of round about 0.5 or higher, it could go up usually to round about 3.0. From round about 0.5 or higher is important. That's good. Okay, that is good, and I'll explain a little bit more why it's good a few pages down. And so the other ones that are on the left-hand column for the variables are statistically significant, but the effect sizes weren't all that great. Now that just means that, okay, we've got something here, we've got something to work with, we're starting to cook with gas here, but the effect size, the magnitude of the difference between the mean for the trial group and the mean for the comparison group hasn't yet got to that point where we're saying we've got a really fantastic lift-off. But in the context of the study, they're very, very important results. Okay? If we flip over to page 2, and if we go down to blending CVC words, what we've got there under the P column is a figure of 0.01, and that just means that there is a 99% chance that if we had another sample of kids in the comparison group and another sample of kids in the trial group who'd gone through the same method or the same program, we would 99% of the time expect to get similar differences. So that's what statistical probability is. But the important point there is on the right-hand column where, on the effect size column, where the effect size is 0.72. Now that's a pretty decent effect size, and a lot of researchers would give their eye teeth to get effect sizes like that. And if you go to the next column, you see 76%, and you're thinking, what on earth does 76% mean? Because it's got nothing to do with 0.71, not that it's obvious. 76% means that with this type of an effect size, 76% of kids in the trial group will do better than the average kid in the comparison group. Okay, that's what it means. 76% of the kids in the trial group have done better, will do better than the average kid in the comparison group. The bigger the effect size, then the less overlap there is between the distribution of scores in the trial group and the comparison group. So that's a really good number. And if we trawl down a little bit further, we've got some others there. Effect sizes 0.55, 68, 69, 50, 69, 68. And they're all important differences. They're all important. And they're statistically significant, which is an added bonus. And you'll see on the percentage column, the trial group is doing better than the average performer in the comparison group. So this is just another way of looking at the data and saying, well, you know, these researchers at Massey and everywhere else, they talk about statistical significance. Can't they talk plain English? Well, this is another way of trying to unpack it and interpret it in a way that people can sort of perhaps relate to. How many kids are doing better? Well, we've got a percentage of kids who are doing better than the average kids in the other group. That's a good result. These are good results.